Number 11 here is asking us, as expected, to find a value c that satisfies the conclusion of the mean value theorem, but they also want us to graph this one, find out that it works out okay. So yeah, let's see what we got right here. All right, so mean value theorem is telling us to take our derivative now and evaluate it at c. So derivative of e to the x is just e to the x, but I'll replace that x with a c here. Equals, on the right-hand side, we're going to do f of b for starters. So putting a 1 in for x, we just get an e. Minus f of a. E to the 0 power is going to be a 1 all over b minus a. That 1 minus 0 is just going to be a 1 there. Boy, and this was not all that exciting because a whole lot of stuff kind of just drops out right here. So, where are we, guys? Our job is to solve this thing for for c. I guess before I do that, I can just rewrite this as an e minus 1. And how do we get rid of an e in front of our exponent? Natural log of the left, and we'll do the natural log of the right. But notice the parentheses there, guys. That's important. We do the natural log of the entire quantity here of e minus 1, not natural log of e and then minus 1. Okay, so the natural log and the e here drop out, and we get c is equal to the natural log of the quantity e minus 1. And as I just said, it's important that everybody realizes you cannot make that the natural log of e minus the natural log of 1. We are not distributing a logarithm here, guys. We can only distribute numbers, constants and variables, but you can't distribute an operation like a sine or a cosine or a square root or a logarithm here. So I think we would just probably leave that where it is right there and just say that our value here is natural log of e minus 1. Now, since they want us to graph this thing, that's going to make things just a little bit more interesting, but I think we can still come up with a decent approximation of what that graph is going to look like here and see what we've got. So for the graph right here, we're graphing y is equal to e to the x, not on a very big interval right here, just from 0 to 1. So this function, of course, is going to look something like this, and going up like this, and there we go. At the spot where x equals 0, I'm hoping we know this here, guys, the natural log of 0, or excuse me, e to the 0 power is 1, pardon me, and then putting a 1 into that function, I'm just kind of guessing as to the location right here, but e to the first power is just e, which is approximately 2.718. And with those 2 points right there, we create a secant line, only one secant line, that connects those 2 points looking something like this, all right? And what do we know about that, guys? That line in green there is our secant, and the slope of that secant is what we got from the right-hand side of this equation, which was e minus 1. Now remember that e is 2.718, so this is about 1.718. And that seems somewhat reasonable for the graph that I came up with, even though I'm drawing this by hand, so I don't want to draw too many conclusions from that. Now, the whole point of the mean value theorem is that there is somewhere in this interval between 0 and 1 where we could draw a tangent line to this curve that would be parallel to that secant. So the c value here would need to be the natural log of e minus 1. And that, you guys, I do not know that off the top of my head right here. Sorry. So I'm going to type that into my calculator here real quick and get the natural log of the quantity e to the first power minus 1. Okay. And I got 0.541. Now again, that is your x value. So 0.541 would be maybe right about here. I'm just guessing here, guys, but I'm going to write that as natural log of e minus 1. And so my point of tangency would be maybe right about here. And we're just asking here, guys, does it seem reasonable that if we were to draw the tangent line to the curve through that point right there, does it seem like that tangent line that we just drew in red could be parallel to the secant line that we just drew? Could it have that slope of e minus 1, which is about 1.718? Well, I think looking at this one, guys, I kind of missed that point just a little bit, but there you go. I think that looks pretty realistic. I certainly wouldn't bet my life on it. I wouldn't say guaranteed that it is, but it seems reasonable enough to assume that that could be correct right there. And I suppose if I graph that on my calculator, we might see a little bit better, but I think this is close enough for government work here for number 11.